right? Magnetic fields are the regions around a magnet where magnetic materials and charged particle feel a force. The particular charged particles feel a force because of the magnet. The direction of the magnetic field is shown by lines of force shown there, while the strength is indicated by their density. As because of the strength is indicated by their density. If there is high density, the strength is more. If there is low density, the strength is less. So definition of magnetic field: a magnetic field is a region around a magnet where the force of magnetism is exerted. So a magnetic field is a region. A magnetic field is a region around a magnet where the force of magnetism is exerted. It can also be created by an electric current, or this field is characterized by its direction and strength and plays a crucial role in the behavior of magnetic materials and electrically charged particles. So characteristics of the magnetic field lines. So what are the characteristics of magnetic field lines? Here is the direction. So according to the direction, magnetic field lines shows the direction of magnetic field and density. So the density of the lines indicates the strength of the magnetic field. Already I said that if the density is more, then the strength of the magnetic field is more. If the density is less, then the strength of the magnetic field is less. So closer spacing of the lines indicates a stronger magnetic field, while wider spacing indicates a weaker field. So wider spacing means it's a very low density, but very spacing is very closer means it's a very high density. Because of high density, there is a number of magnetic lines is more. So that closer spacing of the lines indicates a stronger magnetic field, and while wider spacing, that means there is a much space between among the magnetic lines, so that there is a much spacing is there. So while wider spacing indicates a weaker field. You can show the particular diagram of the magnetic field in front of you. So what are the properties of magnetic field lines? Magnetic field lines are continuous and form closed loops. Here you can see that magnetic field lines are continuous and form closed loops. Right? They are directed from the north pole to the south pole of magnet. The density of lines represents the strength of the magnetic field. So the density of lines represents the strength of the magnetic field. Already we discussed that. So formation of magnetic field lines. So how the magnetic field lines will be formed? That means magnetic material alignment. When a magnetic material is placed in a magnetic field, its domains align with the field, creating magnetization. When a magnetic material is placed in such a magnet, for example, let's take a simple magnet. When a magnetic material, or simply take one iron piece, is placed in a magnetic field, its domains align with the field. It has some reactions, so creating magnetization. Curling iron filling experiments. So there is some experiment is there, curling iron fillings experiment. That is one experiment. There is iron fillings around a bar magnet usually the formation of magnetic field lines following the direction of the field. So right hand thumb rule. What is the right hand thumb rule? There is some rules is there, right hand thumb rule and left hand thumb rule, like this. So Faraday's laws, all those. So experimental marks can be used to observe the direction of magnetic field lines around the current carrying wire. So experimental markers can be used to observe the direction of magnetic field lines around the current carrying conductor. So to give a particular directions of magnetic field and also corresponding current electrical field, there is some rules introduction is there, right hand thumb rule and left hand thumb rule, like this. So what are the patterns of magnetic field lines? Is magnetic field lines forms various patterns around different types of magnets and electrical currents. Magnetic field lines forms various different patterns is there around the different types of magnets and electrical currents. So those are around the magnets and electric currents. Bar magnet lines emergence from north pole, curve around and return to south pole. And the other one is solenoid. Solenoid is a different. Lines are straight and parallel. lines are straight and parallel inside but curved outside. So that's a very important point. I can show you a solenoid here also, two power magnets, unlike pole, solenoid. So this is a solenoid here. So this is solenoid cell. So already we know that the lines in the curved, the lines are straight lines inside, but the outer side have a curved lines. The lines are curved lines out of the solenoid, but it inner those are straight lines. Right, next. So circular loop lines, circular loop. What is a circular loop? Means lines are concentric circles around the loop. So in a particular loop, the lines are concentric circles. In the center, you can see the two bar magnets, unlike poles, attract each other. Two bar magnets, unlike poles. Here, this north pole and south pole, or those are they have this north pole and this north pole and this south pole and north pole, both are unlike poles, so that they are attractive. But this north pole and north pole will be not attractive. That means they can opposite each other, right? And applications of magnetic field lines. What are the applications of magnetic field lines? Means, so magnetic field lines applications, those are nuclear magnetic resonance used in medical imaging to create detailed image of internal body structures, and magnetic levitation, that means enables high speed trains to float above tracks and reducing friction and increasing speed. Actually those are missed here, the image is missed here. Navigation assists in determining directions using compasses, crucial for exploration and travel. So for the navigation also these magnetic field lines are used. So magnetic field lines is a main source of navigation, assists in determining directions using compasses, crucial for exploration and travel. So quality control used to detect surface and near surface flaws in ferromagnetic materials and components. So magnetic field lines in different materials. Ferromagnetic materials have a strong magnetic properties. These are some important materials, magnetic field lines in different materials. What are the different materials is that is very important. Ferromagnetic materials and diamagnetic materials and paramagnetic materials. What are the ferromagnetic materials is ferromagnetic materials have strong magnetic properties, forming distinct and concentrated magnetic field lines. So those are forms distinct and concentrated magnetic field lines. In the same way, diamagnetic materials. So diamagnetic materials create weak and repulsive magnetic field lines when exposed to an external magnetic field. So diamagnetic materials create weak and repulsive magnetic field lines when exposed to an external magnetic field, whatever may be. If we are introducing any external magnetic field only, then these intensities will be shown, right? For example, whatever may be, when you are comparing with the another student only, you can find out what is your rank, what rank you triggered, so that there needs a one comparison, so that external magnetic field will be introduced here. So paramagnetic fields have a tendency to align with an external magnetic field, resulting in aligned magnetic field lines. Paramagnetic